Welcome back, Focus Learners. Okay, so today we are embarking on a pretty fascinating journey. We're going straight inside the most important technological black box of our time. We're going to climb what I like to call the ladder of cognition to understand exactly how artificial intelligence is evolving. And it is literally transforming right before our eyes. It's going from a simple text predictor, something that just guesses the next word, into this deliberate, methodical problem solver. I'm absolutely thrilled to guide you through this explainer today because by the end of it, you're going to see exactly how the gears of machine thought are actually turning. Well, it all starts with a massive fundamental question. Does AI actually think, or is it just guessing? Now, for a long time, large language models gave us this incredible illusion of intelligence, right? They were essentially playing highly advanced autocomplete, spitting out statistical guesses based on vast amounts of internet text. But as we'll see, the field has completely moved beyond that illusion. We are now entering an era of actual machine reasoning, where the AI doesn't just predict, it deliberates. Okay, let's dive into this. Here is the mental roadmap we'll follow today to demystify these new AI methodologies. 1. What is AI reasoning? 2. Prompting and polling. 3. Searching and using tools. 4. Learning through reward. 5. The aha moment. And 6. Putting AI to the test.
Section 1. What is AI reasoning? Moving beyond text prediction.
So, to really understand how machines are breaking away from basic prediction, we first need to establish what constitutes actual thought in a machine. Here's our working definition, pulled straight from the research. Reasoning is learned, compositional computation over latent steps that yields verifiable conclusions. Let's break that down, because it's absolutely crucial. True reasoning means the AI is instantiating and manipulating intermediate thoughts, those latent steps, to piece together a puzzle. It's not just retrieving some memorized surface-level pattern. It's actually breaking a problem down, working through the intermediate logic, and arriving at an outcome we can actively verify.
Section 2. Prompting and polling. Eliciting the AI's internal thoughts.
So how do we actually get a machine to show its work? Well, researchers first figured out how to guide the AI's mind using simple textual cues. Initially, this was through something called chain of thought. By just telling the AI, hey, let's think step by step, we forced it into a single, linear sequence to show its work. But there's a catch. A single deterministic path is pretty brittle. If it makes one tiny mistake early on, the whole answer completely derails. Enter self-consistency. Instead of trusting just one chain, we sample multiple, diverse reasoning paths and aggregate them to find a consensus. By doing this, we harness the statistical power of the model to drastically reduce hallucinations and zero in on the absolute most robust, reliable answer.
Section 3. Searching and using tools. Exploring and interacting with the world.
Internal logic is great, but let's move to and see how this builds when the AI needs to interact with the outside world. To solve truly complex problems, it has to explore. This is where we upgrade from a linear chain of thought to a tree of thoughts, or Monte Carlo tree search. Think of the AI like a grandmaster chess player. Instead of just calculating one single sequence of moves, it branches out. It explores multiple possible future actions, evaluates these partial thoughts, and ruthlessly prunes the dead ends. It is actively planning and backtracking, which represents a massive leap in cognitive capability over just answering a prompt in a straight line.
And we can actually give those branches hands and eyes using something called the REACT framework. It's this really elegant three-step loop. First, the AI formulates a thought, like, I need to know the square root of this number. Next, it takes an action, literally querying a calculator API. Finally, it makes an observation of the result and loops back to refine its plan. The AI is no longer trapped in a text box. It's dynamically interacting with real-world tools to fact-check its own logic.
Section 4. Learning through reward. Shaping behavior through feedback.
Now this is where the training paradigm entirely shifts. Instead of feeding the AI thousands of human examples, we stop giving it examples and start giving it goals. We let it figure out the path itself through reinforcement learning. WebGPT, for instance, learned to navigate browsers for citations exactly this way. Then we have DeepSeek R1, which is a huge breakthrough because it learns purely from outcome-based correctness rewards. It completely eliminated the need for human annotated rationales. You literally just tell it if the final math answer is right or wrong, and it discovers the optimal reasoning strategy totally on its own. And systems like 2RL and Retool, they take this even further, interleaving reasoning with real-time code execution, so the AI actually learns to write scripts to verify its own logic mid-thought. Pretty wild, right?
Section 5. The aha moment. The phase transition of AI cognition. As these models undergo reinforcement learning, something profound happens inside their neural architecture. The researchers describe a self-organizing dynamic where reward gradients reshape latent activations, a phase transition from pattern completion to deliberate reasoning. And this brilliantly illustrates this spontaneous moment where the AI discovers how to structure its internal search process. It suddenly stops acting like a diffuse text generator and crystallizes into a focused engine that searches, plans, and verifies. Basically, it learns how to think.
Section 6. Putting AI to the test. Measuring genuine intelligence.
To prove these cognitive leaps are actually real and not just a clever illusion, we have to subject the AI to rigorous evaluation. Now, what's really interesting about this slide is how we incrementally scale the difficulty to push these models to their absolute breaking points. We start with GSM 8K, which tests basic grade school arithmetic, requiring about 2 to 6 steps. Then we move up to the math benchmark, requiring high school symbolic logic. But the ultimate proving ground is AIME, the American Invitational Mathematics Examination. This is straight-up Olympiad-level math. It requires 5 to 10 deep, multi-layered logical synthesis steps that you simply cannot solve through memorization.
To give you a sense of just how brutal the AIME benchmark is, the answers are integers between 0 and 999. That means if an AI is just randomly guessing, it has a mere 1 in 1,000 chance of getting it right, a 0.1% success rate. You absolutely cannot fake your way through this test.
Which makes this next statistic absolutely staggering. The retool framework, which combines reinforcement learning with that dynamic code execution we talked about earlier, recently achieved a 67% accuracy rate on the AIME 2024 benchmark. Just let that sink in for a second. An AI is now successfully solving Olympiad-level math problems that stop most human mathematicians, and it's doing it by autonomously reasoning and writing verification code on the fly. No way! So the crucial point is this. We've watched AI evolve from just guessing the next word to executing deliberate, multi-step, tool-augmented logic that rivals top human minds. If an AI can now verify its own reasoning, write its own code, and autonomously self-correct, well, what happens when it becomes smart enough to design the next benchmark for itself? That is the frontier we are standing on today. Thank you so much for joining me on this explainer. Keep learning, and I'll see you next time.